For this lesson, we're going to discuss solving right triangles. This is a topic we have discussed before in geometry, and about the trigonometric functions that show the relationship between this right triangle ABC and it's the sides and the angles of the triangle. And what we learned before was the acronym SOHCAHTOA, and so stands for sine, and our angle theta is right here, and the relationship of the sides to make sine of theta is the opposite side, so opposite for O, over the hypotenuse, and the hypotenuse in a right triangle is always C. So in this case, opposite over hypotenuse. In this case, our opposite side to theta, theta is located at angle A, is going to be A over C. Now, SOHCAH is for cosine of theta, is adjacent over hypotenuse. Now, the side adjacent means next to, the side adjacent to angle theta is B, so adjacent over hypotenuse. And in this case, that will be B over C. And then tangent is opposite over adjacent. That's the ta. SOHCAHTOA. And let me fix that. Opposite over adjacent. And in that case would be A over C. So if we know all of the sides, but we need to find angles, there's a function where we can find angle theta by using an inverse function. It's not a reciprocal, and so we would say sine inverse of those sides, opposite over hypotenuse, would be equal to theta, and that would be an answer in degrees. So let's go to the next screen and practice one. Before we solve a triangle, let's start with refamiliarizing ourselves with some of the trig functions and finding the different values for those. Alright, so we have this triangle. We know two of our sides, and that is a 9, even though you can't see it. A is equal to 9 and C is equal to 15. Before we can find sine, cosine, and tangent, we need to know the third side of the triangle, but this is a right triangle, so we can solve it using the Pythagorean theorem. So my a squared is 81, b squared we don't know, that's what we're looking for, and c squared is 225. So we're going to subtract 225 and 81, and gives us 144. So that means that b is equal to 12. Alright, so let's find our trig function. So sine of theta, you see theta is down at angle B. And so sine opposite over hypotenuse, opposite of angle B is side B, always. And so that's 12 over 15, but that is not a reduced fraction, so we want to reduce that. Has a common factor of 3, so that gives us 4/5. Alright, let's deal with our three main trig functions. Second one, cosine of theta, is adjacent over hypotenuse. My adjacent is that 9, and 9 is over 15, and we're going to reduce that as well and make that 3 over 5. And then the last one is 4 over 3, because opposite over adjacent. Now, we went over in class that the reciprocals of these functions, the reciprocal of sine is cosecant, and so all you're going to do is flip them over, and then the reciprocal of cosine is secant, flip that one over, and then lastly you'll do the same with cotangent. Okay, so to solve the triangle, when we say solve the triangle, that means identify all 6 parts, all 3 sides, all 3 angles. Now, if this is a right triangle, so the first easiest thing to do is fill in that angle C is 90 degrees. The second easiest thing to do is to recognize that a triangle has 180 degrees, angle A plus angle B plus angle C equals 180 degrees. Angle C is 90 always, so that means the other two angles we remember from geometry, angle A and angle B, they add up to 90, and since angle A is 30, angle B is 60. Now, I've been given one side. Now, if you notice, angle A and side A are opposite. The side and the angles are always opposite, have the same letter. Also, this is the 30, 60, 90 triangle. And what we remember is that there's this great ratio with 30, 60, 90. Now, the short side is A because it's opposite the small angle. And what we remember from geometry is that the hypotenuse is double the short leg. Well, A is equal to 6 is my short leg, so that is 12. And the long leg, which is side B, is the square root of 3 times this. And there we go. And that's how you solve a triangle.